Alright, in this clip I'm going to be looking at the A star questions from this WJEC higher tier Unit 2 from the summer of 2018. The CB questions are the first 9, questions 1 to 9, and I've covered those in a video clip for the second half of the intermediate tier, which is its overlap. So all of those questions are already covered. So we're going to start with question 10. So question 10, you are looking at a factorization, and it's a special case of a double bracket factorization that you should have been trained to look for. It's called the difference of two squares, and it occurs where both terms in the expression are actually square numbers or square terms. So because I recognize that 4 is 2 squared, I can write it as 2 squared m squared, and because I'm looking for this as a difference of two squares, because we have the subtraction, I just need to check that 289 is a square number, and it is. So I can write that as the difference between this square and this square. And again, what you will have learned if you had revised this is that that can be then written down straight away as the product of the 2m plus 17 and the 2m minus 17. So that's literally something that you're looking to spot in a factorization question on the higher tier, is the difference of two squares. Now you can always check you're right just by expanding it back out using whatever expansion method you've been taught. Question 11. Calculate the volume of a pyramid with a base area of 13,200 square centimetres and a perpendicular height of 460 centimetres. Volume of the pyramid, I'm pretty sure you're not given. Let's just check. No, nothing there for the volume of a prism. Of a pyramid. So it's one that you need to know, and what you need to know or remember is that if you've got the width and the length and the perpendicular height, the volume is width times length times height divided by 3, or 1/3 width times length times height. Well, width times length gives you the area of the base, which is what we've been given here, so we know what that product already is. So 13,200 times the height, which is 460, divided by 3. So work out what that is. Type it in exactly as we see it. So we've got 13,200 times 460 on the top and 3 on the bottom. That's 2024000, and that's going to be in centimetres cubed because we've multiplied the centimetres squared by a centimetre to give us centimetres cubed. Now we want to turn that into cubic meters. So if we were turning length centimeters into cubic meters, centimeters into meters, we would divide by 100. To change area centimeters squared into meters, we would have to divide by 100 twice, because we're multiplying hundreds by hundreds when we're working on an area, and we would have to divide by another 100 again when we're working with volume. So we're going to be dividing by 100 by 100 by 100, or another way of writing that is dividing that divided by 100 cubed, or 100 times 100 times 100. Whichever way you do it, you should end up with the same answer. So if I divide that by 1,000, divide by 100, divide by 100, I get that. 2.024 meters cubed. So repeatedly divide by 100, or divide by 100 cubed, or divide by, and then in brackets 100 times 100 times 100. The important thing is that you're dividing by 100 3 times for each of the dimensions that you're turning centimetres into metres. Question 12. 5 quadratic equations are listed below. Draw a line connecting each equation to its solution. So they've done one for us, so we'll move on to the next one. It's already been factorised, so we're going to say either x equals 0 or 2x plus 3 equals 0. Take the 3 over and divide by the 2, and we get either x is 0 or x is minus 3 over 2. So 0 minus 3 over 2 is that one. So that's that one. Here, double brackets, either that one equals 0, which will give you x equals 1, or 2x minus 3 equals 0. Take the 3 over, it becomes positive, divided by 2. So I'm looking for 1, 3 over 2, which is there. This one, either 2x minus 3 equals 0, which will be same as that, x is 3 over 2, or 2x plus 3 equals 0. Take 3 over, it becomes negative. So 3 over 2 or minus 3 over 2, which is there. And for this one, with the square root both sides, square root of 0 is 0. So that's the same as saying 4x plus 9 equals 0. Take the 9, becomes negative, divide by 4. So for that one, we're looking for x equals minus 9 over 4. So there's only one solution for that one. Okay. Question 13. So the values A27, B1.9, C0.81 are each correct to two significant figures. Use the formula D equals A minus B, all divided by C, to calculate the least value of D. So again, if you haven't revised error bounds or accuracy in measurement, then you need to do that before watching this, otherwise it won't make any sense. But for A is going to be anything between if that's been rounded to two significant figures, 26.5 is going to be the smallest number that when it rounds up will give you 27, and the largest, and you will have had this debate with your teacher, we know from when we teach rounding that would actually round up to 28, so it's actually on the limit between those two, and we can resolve that with inequalities by saying A is greater than or equal to that, but it's less than that. However, when we come to calculate with limits, we will be using the larger value inclusively within that calculation. So A is going to be any value between 26.5 and 27.5. B, if that's two significant figures, the smallest number that would round up to that would be 1.85, and at the other extreme it would be 1.95, even though we know 1.95 would round up. So once again, those inequality symbols cover that issue. And then for C, if that is rounded to significant figures, the value down from that would be 0.805. There's your two most significant figures. You look at the next one, it would round up to 0.81, and on this side it would be 815. So these are the figures, the values that I'm going to be using to determine the least value. Now for that to be as small as possible, so let's call it d min, when we're dividing, to get a small answer, we want the smallest possible number on top divided by the largest possible number on the bottom to make your answer small. So we would want a minimum value on top divided by a maximum value. So the maximum value on the bottom is easy. It's going to be 0.815. Now, when we are subtracting those, if we want that subtraction to be as small as it possibly can be, then we would want the number that we're subtracting from to be as small as possible. So that would be A min, and we would want what we're taking from it to be as big as possible, B max. So A min is 26.5, B max is 1.95, and we've already worked out that the maximum value for C that we use is the upper limit. So that's what we're going to work out. 26.5 take away 1.95 on top, divided by 0.815. So the minimum value is going to be 30.122, etc., etc., etc. So that's that. Question 14, arc length. So if we had the full circle there, then the circumference would be pi times 2 pi r, so pi times 2 times 3.1 would be the full circumference, but we've got a fraction of the circumference, and the fraction of the circumference that we've got is 191 degrees out of 360. So in order to work out how much of the circumference we've got that fraction of the circumference, which we can work out then. And again, I'll type it as you see it. There are any number of ways of typing this in. So 191 degrees out of 360 times the circumference. So 10.3, they're giving it to 1 decimal place, so we can give it to 1 decimal place as well. Question 15, fractional algebra. Again, this is one where I'll have to assume that you've been taught a method here and you just want to check what you've done. The way that this works, when you learn to add and subtract fractions, the first thing you do is get taught equivalent fractions, but then from there you may discover your own sort of shortcut method, and that shortcut method transfers quite nicely to algebra. So if we had something like 2 11s plus 3/5, say, then to work out what that is, the denominator becomes the product of the two denominators, so you end up with 11 times 5 underneath, and then this value here is what you get when you multiply those two together, so 2 times 5, and similarly the second value would be 3 times 11. So you end up with 10 plus 33 over 55, which is 43 out of 55. So that's a method you will have probably discovered in Key Stage 3 when dealing with fractions. Same system applies with algebra. So we start with 2 3x minus 5 take 7 11x minus 13. The denominator becomes the product of those two. Then we multiply those two together. That minus is there because we're subtracting. Then we multiply these two together to get that. Now when we're simplifying an algebraic fraction, we don't multiply out the factors that are on the denominator, because sometimes when factorized they'll cancel with terms that are in the numerator. So we don't expand that, but we do expand the algebras on the numerator part of the fraction. So 2 times 11x, 22x minus 26. Then with this bracket we get minus 7 3's 21x. Minus as a minus is a plus 35, 7 5's. And then we got 22x take away 21x is x, and 35 minus 26 is 9. So we get x plus 9 over 3x minus 5, 11x minus 13. And we can't simplify that any further. If one of those factors under there had been an x plus 9, we could have cancelled, but that's as simple as that gets. Bit of probability. The bag contains 200 beads. Some of the beads are red. A bead is selected at random. Its colour is recorded and then the bead is replaced. A second bead is selected at random and its colour is also recorded. Probability that 2 red beads are selected is 0.1369. Calculate the number of red beads in the bag. Well, we're going to resort to algebra here, but just to work out how we're going to use the algebra, let's say there were 70 red in the bag. So if there was 70 red, the chances of you drawing a red the first time would be 70 out of 200. Then the bead is put back in the bag, so the second time you pull one out, the probability will still be 70, because there's still 70 red in the bag, out of 200, because the bead was put back in. And the chances of it happening with the first bead being red and the second bead being red, you should know the trigger that when you're using the word and in probability, that means times. So we'd work out 70 times 70 over 200 times 200, and that would give you the chances of 2 red beads being selected. The difference in this question is we know what that comes to. We know it's that, but what we don't know is that. So if we say let n be the number of red beads, then what we're working with, that's the chances of the first one being drawn and read and the second one, and that equals that. When you're multiplying fractions, you multiply the top, so we get n squared, you multiply the bottom, 200 squared is 40,000. To get the n squared, we multiply both sides by 40,000. So times 0.1369, 5476, and then to get the n, we have to undo a squared, which gives us 74. So there's 74 red beads in the bag. Okay, question 17. I can see that I'm going to be expanding a pair of double brackets, so I'm going to end up with x squared terms, and that 2 decimal places there is a trigger for quadratic formula. So in order to solve this equation, I've got to use the quadratic formula, x equals minus b and so on, which I can't remember, you given, which you are given in the formula book there. So we need to get our equation into the form of an x squared number, an x number, and a number only term equals 0. So that's the first job. So expand the brackets, multiply 2x by 3x, 6x squared. 2x by negative 11, minus 22x, then plus 15x, and finally minus 55. Now that equals 7, mine needs to equal 0, so that needs to come and become negative. So I'm taking 7 off both sides. X squared term, 6x squared. Minus 22 plus 15 will be minus 7x, and minus 55 minus another 7 is minus 62 equals 0. And just check that. 6x minus 22x plus 15x minus 55. Okay, compare that with the formula ax squared, so 6 is a, b is minus 7, and c is minus 62. Into the formula, x equals minus b, so it's going to be minus, and b is minus 7, plus or minus the square root of b squared minus 4 times a times c all over 2a, which is 6. So before I start thinking of calculator work here, I need to do some tidying up. That becomes plus 7. Negative 7 squared is 49, plus 24 lots of 62. All over 12. Plus or minus the square root, 49, 1537, all over 12. So now I can go to my calculator. So either x, we take that as being the plus, type it in exactly as you see it, square root, fraction on top, 7 plus root 1537 all over 12, 2 decimal places, 3.85, or x is the subtraction. minus 2.68. So again, that would have been one your teachers would have taught you to hunt out on a calculator paper, and the trigger is it's a quadratic because you can have an x squared, and the 2 decimal places means it won't factorize by inspection. Rearranging formally. More complicated when the letter that you're trying to rearrange to get appears on both sides. So to get inside it, I have to get rid of the square root. To deal with the square root, I have to square both sides. So I'm squaring both sides. When I square both sides, this side just becomes gc squared minus v. And I square that side and I get c squared. Everything with a c in, I want to get on their own on one side. So I'm going to deal with that. It becomes a minus c squared on the other side, and that becomes a plus v when I deal with that as well. So it's applying your laws of equations. Now, here, c is common, or c squared is common to both parts of that expression, so I can take it out as a common factor, leaving me g minus 1 in brackets. C squared times g is gc squared, c squared times minus 1 is minus c squared. I want the c squared on its own, so I have to divide both sides, that's joined by a times, divide both sides by g minus 1, and then to get the c on its own, I have to square root. Now, what I'm not sure, unless I saw the answer, the mark scheme, is whether they would expect you at GCSE to realise that when you take a square root, you have to have a plus or minus. For example, if you take the square root of 4, it's 2 or negative 2, because both of those, when you square them, will give you 4. So really, that should have a plus or minus on it, and certainly at AS level, without it, that would be penalised. I'd have to see the mark scheme to know whether or not there's an expectation for you to put that plus or minus there. And then the final question, quite a crafty one really, because you look at it and immediately you're thinking circle theorems. And there is a circle theorem element to it, but not initially. So BC is the tangent to the circle at point E. EC is 8, and AC is 11, and DCE is 31 degrees. Now, once more, just like with a quadratic equation, quadratic formula question, you should be expecting on a calculator allowed higher tier to be working with sine rule and cosine rule. And this is the last question on the paper, and we haven't had it yet. So even though on first glance it looks like a circle theorems question, in reality, to find the length, AE, it's got nothing to do with circle theorems. What we've got AEC, we want to find AE, we know AC is 11, and we know EC is 8. So this is in fact a cosine rule question, because we're trying to find the opposite side to the given angle, and we know the length either side of the given angle. So AE squared, you are given this formula, I believe, on the front, but it's certainly one that you should know how to use anyway, even if you've got different letters. It is the sum of the squares that you're given minus 2 times their product times the cos of the angle between them. So that's just applying the formula you're given on the front. So we got 121 plus 64, 185, minus 22 lots of 8, 176, cos 31. Make sure your calculator has a little d in it for degrees. If it doesn't, as with any trig questions, what you have to do is go, what did I do then? Shift, setup, and 3 for deg. It's really important that you're working in degrees, otherwise you're going to get some pretty crazy answers. So AE squared is 185 less 176 cos 31 equals 34.138 blah 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 blah. Doesn't matter. I'm not rounding it yet. I'm keeping that on my screen because then I have to square root it. When I square root it, square root of ans 5.8 or 5.84. It's not telling you to give to a specified degree of accuracy, so 5.8 is fine. So I now know what AE is. Then it says calculate the size of CED. CED is this angle here, and this now is where the higher tier circular theorem bit comes in. The one circular theorem that isn't taught at intermediate tier is the alternate segment theorem, which is like a kind of backwards Z angle in a parallel line. That angle there is the same as that angle there. That angle here is the same as that angle there. That's the alternate segment theorem. So in order to work out this angle, which is what they want, I can go back to this triangle and using sine rule work out that angle there. So if I call that theta or x or a, doesn't really matter. So using the sine rule, 8 over sine theta is that one over sine 31, and I know that that one is 5.8. So the sine rule again, you need to practice. If you haven't practiced it, that would make no sense to you whatsoever, but it links the sine of the angle with the length of the opposite side. So that over that was that over that. Bit of rearranging here. I can bring the sine 31 up, I can bring the sine theta up that way, and so I get 8 sine 31 equals 5.8 sine theta. To get the sine theta on its own, I'm going to divide by 5.8. So sine theta equals 8 sine 31 divided by 5.8. Theta, well, let's work that out first of all, just so we're not doing too many steps in one go. So 8 sine 31 divided by 5.8 equals 0.710 blah 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 blah. To find the angle, we do shift sine, the inverse, that's still on my calculator, so I can use the ans button. Shift sine ans close bracket 45.3 degrees, and that's what theta is, because they all using alternate segment theorem, angle CED equals angle EAD equals 45.3. And that's it. That's the end of the paper.